This is Hemalatha, Department of CSC Data Science, and I'm from BVR IT Narsapur. My course name today I am going to discuss about artificial intelligence search algorithms. How does it work and all. Topic is search algorithm. So in search algorithm, first basically in artificial intelligence, what we will do, we will find we'll have some graphs, we will find the optimal paths, we'll have search techniques. Each and every search techniques have different methodologies. Like based on the search technique, we'll have our goal state. Then it is like we'll be building the agents, and most of the time it will perform the search algorithm task as a given task. In the state space, whatever the space has been provided to search that, we will start from the start state, then we'll go to the goal state. The goal state will check if the current states returns or not. That will be based on the heuristic. Coming to these types of search algorithm, we have two types of search technique. One is informed search, other one is uninformed search. Uninformed search, we also call it as blind search. In informed search, we have greedy search method, A** search, and different search techniques are there in uninformed search. Both informed and uninformed have many methodologies, many search techniques. Whereas when we speak about uninformed search, no additional information or goal node has been provided, and as the word itself says uninformed, it is a blind search. Like we don't know like how to travel, where is my path, how to find the goal. That will be little bit like blind. It's like a blind search technique. And sometimes we'll have non-goal state also, I can say. And for example, we have two types of search methods, like very basic, all the students has to understand is we have BFS, DFS technique, breadth first search and depth first search. As we know that in breadth first search, we will visit all the nodes. No node has been left unvisited. We'll search level by level. Then we will find our goal state. But here we can say that it's little expensive and it takes time complexity. Everything will be here. For example, in DFS, we have some unvisited nodes also, and some that unvisited nodes, if you find your goal states in between, the rest of the things will not visit. So for example, here in DFS, we can say that it starts at a root node, explores as far as possible, and once you explore, then you reach your destination, I mean goal state, then you go back. So you will go back to your source where it is, like it follows, it's implemented using the stack method. For example, in the given graph, I have to travel from A. So this is my initial state. From the initial state, I have to reach the goal state. So where is my neighboring node? Here my neighboring node is like B and C. This is my neighboring nodes. I have to travel each and every path. Linear. I can say linear search. Okay. So from B, again I have to go to D. As it is shown, we have to go to D. From here again I have to go to E. All the neighboring nodes one by one we have to explore, then we have to travel. So for the D, again I have the neighboring nodes C and F. This way you have to travel. Then once you find, here we find our goal state. Once I reach my goal state, then again I will go back. Then I will start my search method. Okay, like one by one method. All the searches, wherever I find goal state, there I will explore. Then I will travel till I reach my goal state. So this we call it as also backtracking. DFS is also called as backtracking. Initially I have goal state. From the goal state A, I will be taking the nodes, neighboring nodes B and C. I will be checking wherever possibility where I can travel. Then I will be traveling the neighboring nodes B and C. Then from the B, I have to fringe. I have to remove that. It can be expanded. I have to go to the next level where the child node is there. From there again I will be traveling to the next level. From again the node B is removed. When I travel to the child node, when I visit the child node, again from the D, it will be fringed. So then at the same time I have to watch my methodology of traveling till I reach my goal state. Finally, I'll be keep on traveling. Now node C is removed, first B is removed, then D is removed, then C is removed, then the child G is pushed in front of the fringe. I find my goal state. So this is how the solution path will be found. Also we can say that from A to G, A is my traversal path, from A to G, from initial state is my A, G is my goal state. The path I am finding one by one, visiting all the nodes, that is where the algorithm terminates. I can say the traversing graph for this is A to B to D to C to G. This is how I will be traveling to find my goal state. So all the methods given, heuristic or search methodology, what has been asked, we have to be very careful what has been asked and how I have to solve this search strategy. Now, see, whatever the search methodology, the ultimate aim is to find the optimal path. Optimal path, we frequently heard the word optimal solution, optimal path, optimization. What does it mean? It means that we will be finding the best path possible. For example, you are inside the campus, in our BYRIT campus. You are designated in one block as a student. Someone is searching you. So how do you search? So first I have to take my entry from in-gate. From the in-gate, I have to look into the blocks. Then I have to come to that designated block. Then I have to find you. The same, best possible method. So by this way I will be coming, but I will not be visiting all the blocks one by one. Then I will not be searching you in all the blocks. In the designated block I will come. The same way, finding optimal method, I can say that whatever the search has been, space has been provided for us. For example, I have taken our BYRIT Narsapur campus. The complete campus is my search space. Where I have to find you, that is in the designated block. So this is how the exploration will be. This is how the procedure we can speak about. Okay. Then once you find, then you will be returning back to the optimal solution. Here, what is the procedure? How I am searching you? Here the example I have taken is British Museum procedure. What I will be doing? I will be exploring. I will be exploring the campus. I will be exploring where the particular block where I have to search you. After exploration, then I will be returning the optimal solution. That's ultimately you. I find you. Okay, then we'll end. So we call it as brute force method. Now, coming to my optimal path finding method. So search as little as the space as possible. Once I want to explore all the areas, all the spaces provided, it will be little clumsy and I will not find the ultimate solution. I will not be guaranteeing the optimal. So here we call it as a heuristic refinement. I will be refining. How I will be refining? There will be a set of candidates. I'll have a search algorithm. Then it has an estimated cost. Obviously, for the estimated cost, the lesser path or the lesser cost will be preferable. Now, when we look for the partial solution, we have to find the best solution. I'll be taking the example of branch and bound technique. So, how I'll be branching, then how I'll be bounding, then where is the cheapest solution found? Where is the less possibility found? That will be my branch and bound technique. First, I will organize the space and that does not prelude any solution. In the complete state space provided, we have partial sequence of moves. It will be extending to each move. We will have some refinement space also, where finally I will find the abstract solution. Now, by looking at the refinement in this technique, so we are speaking about branch and bound technique. By looking at the refinement, it is based on the cheapest candidate, I mean the particular node. A complete solution has been found, then compare the previous one and the next one. Then you have to calculate the estimated cost, as well as once you find the estimated cost, you have to go to the traversal graph also. Now, look at this algorithm. Open. What you will be doing? You will be starting, you will be start searching, then you will be finding your cost. Each and every nodes you will be working, like each and every level you will be looking at the child nodes. Then you will be looking which child node I have to explore, which has the lesser value I have to explore. Then once you find true, then you have to go to the empty. If it is not, then you have to return failure. Pick the cheapest node from the given child node. The n is your given child nodes. If the goal state, in the goal state, you have to reconstruct a path. Every time you have to reconstruct a path, then you have to compare it. Then move to the next generation. How you are generating your nodes? That's very important. Once everything has been found, then you have to take the least bound, I can say. Also, you can say the cheapest solution possible. That's how we will be working. Now, this is my graph. So, what we will be doing? So, my start node will have source node. I can say source node will have A, B and C. Source node will have only these three possibilities I have, A, B and C. Then I will be working on taking tiny graphs. I will be working on how I am going to reach the goal state. From the source node, ABC has been given. My A value is 3, B value is 4 and my C value is 8. Coming to ABC, this A value, whatever has been given, that is the lesser value. So, I have to opt this. This is what I want to explore to the next level. Every time when you are exploring, please do remember you are clear with which one you are exploring. Now, I have taken the A node as it is showing the lesser possible path. So, then from the source, again I will be taking A, B and C. A I have 3, B I have 4, C I have 8. So, this A I am exploring. From A I will be traveling to where I am exploring. A I have 2 sources again, that goes to B and E. Now, my calculation should be from B to A to source. B to A to source. I have to calculate the path that way. When I am taking the traversal graph, I have to come from source to goal state. When I am taking the traversal graph, I have to come from source to traversal state to the goal state. Whereas when I am calculating, then I have to calculate based on the path what I am traveling. Now here, after making our clear with the exploration, then I will be traveling to my exploration from B. From B, I will be again taking my graph. I have to check where are the sources. I found A and D. A I found 6. Then D I have found 7. Okay, 3 plus 4. Now, coming to exploration, A is done, B is done. Then again you have to go to C. Go to C. In the C, you have to check what are the possibilities of exploration. What are the possibilities of exploration? From C, I can found D. I found G. Only 2. From here I am exploring from C. I am source. Going back to source. No need to go to the source. I found the goal state. Now this is my estimated path. Once you find this way, you have to explore all the possibilities of the children know the cheapest solution. From there you have to keep on exploring till you reach your goal state. Here I will be exploring from B, D to A. From A I am exploring B to E. Again in C, each and every exploration, how I will be finding the goal state is important. See, from A I am traveling to B. From B to D. From D I found my goal state. I found my goal state from the traversal path A. I found my estimated cost 12. From A, I found my estimated cost to 12. Now from I have to check from source to B to goal state. How I will be traveling. From source, I will be traveling to B. Then B to D. Okay, coming to this A, we have to show the traversal graph also, right? In this traversal graph, source to, when you speak about traversal graph, you have to show S2, A2, B2, D2, G. So, one way we found the path, optimal path finding. A, I got 12 and this is my traversal graph. Okay, A, I got 12. Now, coming to B. Here B, how I will be traveling from source to B, B to D, D to G. Here my estimated cost is 12 and I will be traveling from S to B to D to G. B, from B I'll be getting 11. Okay. So then I found A, I found B, then I'll be exploring through C now. So from the source to C I have only two possibilities of exploration. One is D, other one is G. Now my goal state is again 11. So this is what I have found till now. Then I'll be trying to explore more based on the children notes. Here, out of the estimated path, how I'll be traveling, I'll be trying to find the goal state. If comparatively anywhere I found this is the lesser value possible, that will be my finalized, I can say branch and bound technique, finalized path traveled. I can terminate there. Now comparatively we got 12, 11 and 11 value. Now our exploration till E is left. Till E value has been left. Now I'll be trying to travel source to A to E. Again we find one more goal state. From the E I am getting D and G. Try to explore more and compare, at the same time compare the values, more or less whatever you will be getting. At some point of time you will be finding that okay, this is fine. Okay, this is where I got the lesser value. That lesser value will be your final solution. Okay, here my goal state is 10. So how I am getting, like, I'll be calculating, then the estimated path I found 10. This is my final value comparatively. Here I'll be terminating. Now my branch and bound terminates here. As I found, this is my final solution. This is where I am terminating. This is my optimal solution. This is how the branch and bound technique and the search works. Some of the graphs will be there. Here you can see that only path has been given, path values has been given. Some of the questions, like in some other search methodologies, you have the node values also will be given. So you should be very little cautious, like how the question has been asked, what we are searching, how we will be finding the goal state, and what is the time. Time management is again very important. In the time given, are you able to solve this? How many steps you will be deriving? That where we have to terminate, where we have to close it. That we should work it on. Until we practice, we cannot do it. So you have to practice more. Then you will find the logic, where you are exploring, how you are comparing. These things will be easier for us. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.